So hello everyone and welcome to Physics Wallah guys. Hope you all are doing well and your preparation is going to the up to the mark and you are preparing well in your all of the subjects. Not only signal system, you have lot of subjects for your gate examination. That is control systems, EDC. These are the subjects which are dealt by me in this channel. Many other faculties are there, but they will give you some other lectures or in these lectures also. And the point is that here we have a faculty pool which will clear all your doubt, and it's a one-stop solution for your all your gate problems. Okay, so now I am here again. This is the fourth lecture. Today I will cover, that is elementary signals. Okay, and what do you mean by the elementary signal? That thing we will cover in the lecture, but the point is that we will first recap our lecture and we will cover little bit elementary signals on DTS also, because we have covered elementary signals on CTS in the last class, but we haven't covered, that is, we haven't covered elementary signal in DTS. Okay, so this will cover today itself, and then we will start the elementary. Sorry, we haven't covered the operation of DTS in the last class. We will cover today, and then we will cover the elementary of CTS and DTS both. So if my voice is clear, let me check also. If my voice is clear, then please let me know. And those who are present, please share this lecture to the maximum students. Guys, class will start daily at 7 p.m. sharp, Monday to Friday. And please do benefit with this series, and that is use my experience of nearly 15 years. Okay, so let's start now. Let me check that voice is clear or not. Hello everyone. Okay, I think my voice is clear. Yeah. So welcome all. So let's start the lecture now. Guys will join in a few moments. I don't think that they all are very punctual. Maybe they will join in few minutes or few hours or few days, whatever, that depends on their mood. But let's start the lectures now. I think there are 5 guys already present here. So let's start the lecture, guys. Let us recap what we have covered in the last class. See here, we have covered the operation part. Okay, we have covered the operation of signals. So in which I have covered, that is mainly x-axis operation, x-axis operation, x-axis operation here, and in this x-axis operation we have covered 3 things, that is time shifting, time scaling, and time reversal. So these are the 3 things. Good evening Vaishnavi. So these are the 3 things that we have covered in the last class. Okay, and let's quickly write the format for each of the signal. For example, the time shifting format is this one. See here, if I call it to be time shifting, then the format would be x of t plus minus of alpha. The time scaling, the format is x of alpha t, and time reversal, we will say that yt is x of minus t. So whenever you have Okay, so what do you mean by time shifting? See here, one student is saying, very good evening to all. One student is saying that we, good evening, Anshuman. So one student is saying that what is time shifting? See here, what do you mean by time shifting? Time shifting is simply that shifting the signal in x-axis in nothing but my towards right or towards a left. For example, if we have a plus sign here, then we are saying that we are advancing, and if we have a minus sign here, then we are saying that it is a delay. Okay, and alpha in all case belongs to a real. Alpha in all case belongs to the real, and this is the thing that good evening Anshuman, this is the thing that we have covered in the last class. Okay, now the point is that, see here, just a minute, one important thing I have covered in the last class is the combined operation, if you remember, and I say that I have, for example, yt is equal to x of alpha t plus beta, then this can be done in two ways. Either you will take alpha to be common, and this is t plus beta by alpha, and or you have x of alpha t plus beta, and here we scale by alpha and shift by beta by alpha, not beta. This is very important thing. Here we can, here I am doing operation in this format. You can do operation in this format where you shift the signal by beta and scale by alpha. So my claim, good morning Hemlata, my claim was that in both the operation, either you perform from the right side or you perform from the left side, this we call it to be combined operations, the result we are getting is exactly same. Okay, the result we get is exactly same. Now the point here is that, see here, listen carefully, this is the thing that we have covered in the last class. Now the same thing we have to cover for DTS also, okay, discrete time signals also. Let's talk about the same thing for discrete time signal, and hence today's class, the main objective is, first is operation on DTS, that we will cover, and then we will cover a elementary signal if time permits. Elementary signals. Okay, this is the topic that I have to cover. Good evening Anshuman. This is the topic that we have to cover in the last class itself, but it's okay, we will cover in today's class. Now let's talk about the operation on DTS, okay, on DTS signal. Good evening Geeta. Now what do you mean by the operation on DTS signal? See, listen carefully. I said that I have a function x of n which is a comma b comma c comma d comma e. Here is the arrow. I told you that how the DTS functions look like, and let's take the pictorial representation of this DTS is this one. See here. Okay, so this is, let's say, A, B, C, let's say here also, here also. And let's imagine that this is, for example, 0, it is 1, it is 2, it is 3, this is -1, this is -2, and this is n, and hence this is xn. Let's call it to be a A, B, it is C, it is D, it is E, it is F. Let's say this. Good evening, Gen mode. So what I'm saying is that, see here, this is a simple function x of n, which is known to me. Now, first of all, I have to tell the parameters which is required for or operating this signal. In the CTS, if you remember, the parameters was width, endpoints, and the height of a function, yes or no? And we are operating either changing the height of a signal, though we haven't changed yet, but we will change the height of a signal, we change width of a signal, or we will change the operating point of a function. Here also we will do the same thing, but in little slight different manner. See here, if this is x of n, and this is a pictorial graph of x of n, then first of all let's define the width and endpoint of a function. For example, here the width is starting from -2 to 3. So the total number of sample is the width here. So when I say about the width of a DTS, width of DTS, then it is number of significant sample. That's a very important point. Significant sample. Okay. What is the meaning of significant sample? See here, significant sample means how many samples we have. See, 1, 2, 3, 4, 5, 6 I have. So here in this example, the width is 6. Width is 6. Okay. So here the width is 6. But the point is that, sir, can you formulate under some formula? Yes. See, this is the upper bound 3, and that's the lower bound, which is a -2. 3 minus of -2 will gives you 5. But see, you have to count the sample at 0 also. So the width can be also written as upper bound minus lower bound plus of 1. You will say like this. So this is the upper bound 3. This is the lower bound -2. 3 minus of -2 becomes 5, plus 1 becomes a 6. Why this plus 1 comes? The plus 1 comes because we want a sample at origin also. Okay. So if you will not include this origin sample, then surely the answer will be only 5, which is not this answer, number of significant samples. But in the last class, if you remember, that I told you about the significant and insignificant when zeros are there. For example, let's consider one very interesting thing, that suppose I have, example I am saying, suppose I have a signal A which is 1, 0, 0, 0, let's say 1, and here it is B and it is 0, 0, 1, 0, 0, 1, 0, 0, 1, and let's imagine that here is an arrow. Let's imagine that I have arrow here. See, suppose I have 0, 0, 0, 1, 0, 0, 0, 0, and so on, and here is a width. In all the cases, let's find out the width of the function. What is the width of the function in all the cases? Listen carefully. What is the width of the function in all the cases? Let's find out. It's a very interesting case. See here, look at this one. I told you in the last class that whenever the 0 come inside, that's in between the significant samples, what I'm saying is that this is the significant sample. Both the samples are significant in nature, and hence if 0 comes in between the significant samples, then you have to count it. So this is n is equal to 0 point. Let's change the color. This is n is equal to 0 point. N is equal to 0. This is n is equal to 1. This is n is equal to 2, and this is n is equal to 3. Okay, and hence what is the width of this function? 1, 2, 3, 4. So this is 3 minus 0 plus 1 becomes 4. This is significant. But my question is that whether you have to count these two zeros, or the zeros after this one. No, it's not necessary. I told you in the last class that these two zeros are insignificant in nature. Why? Because there is a trail of zeros from -1 to this sample. So if you count that what kind of samples we have, so this is the 0th sample I have, and this is -1, this is the -2th sample I have, this is the first sample, second sample, this is the third sample, and this is the fourth sample. So this n value is 4. So if n value is 4, then what up to what? Up to which sample you have to count the width. So this is 4th and this is a -2. So 4 minus of -2 plus 1. So this becomes a 7th, I think so. Or if you count, then 1, 2, 3, 4, 5, 6, 7. So number of sample is, width is 7, or you will say that it is a 4 minus of -2 plus 1, and this gives me 7. This gives me 7. Okay, so this is the width when a DTS is concerned. For example, here, see, here there is a trail of zeros up to infinitive, trail of zeros from minus infinitive. So this means that minus infinitive to this, if this is the n is equal to 0 sample, if it is the n is equal to 0 sample, then there is a trail of zeros present up till infinitive. So you do not have to count this one. So this is nothing but my 0. This is the only samples which is present at a 0, and hence the width is 1. Or if you want to formulate, this is present at n is equal to 0, so the upper bound will be also 0, lower bound will be also 0, and hence it is 1. Is it clear? So what I am saying is that this is the width formula we have in this one, in as far as DTS is concerned. And the end point here is -2 to 3. The end point here is, see, if you count, then it is from 0 to 3. Here if you count, -2 to 4, again here it is count, this is nothing but 0. Now my objective is to change the endpoint, to change the width, and to change the height of the function. For example, if you check the height, what is the maximum height we have? The maximum number of samples, considering that a is greater than all the samples, because I have used a variable here. So I'm assuming that a is higher than every other samples. This means that the maximum value is a. Now this means that I have to change the values of a for this complete A or E or B, whatever, for this signal. This means that I want to change the height of a function. So that's what the meaning of nothing but my changing here in a DTS. Now we will do it in the same manner, but there is some slight difference, and the difference you will notice is in a scaling operation. Basically, that is time scaling operation. You will definitely that is feel the difference. But before starting this one, let's say that, sir, suppose someone asks you that what is the value, find the value. Let me say a question. Suppose xn is given, xn is plotted, find x 4.5, x 3/2, x minus 7/3. My question to you is very simple, that whether you able to find these functions, whether you able to find this x 4/5, x 3/2 minus 7/3, whether you able to find this function? No, it's not possible, mind it. It's not possible. Why? Because I told you that we have a function x of t, and I am sampling it over nts, and we will get x of nts. Then by normalizing we will get xn. My point is that, see here, listen carefully, that this ts here, okay, this ts is a sampling interval, the gap between two samples. But the point is that whatever be the gap defined, but we are doing integer sampling. So this means that n must belongs to integer. This is the thing that you have to take care of. So this means that if n is belongs to integer, this means that no non-integer samples is defined. So if you suppose, for example, if you were asked to find out that what kind of samples I have, what kind of samples I will present here, then mind it that these all samples are nothing but my 0. So they are straightforwardly 0. This is 0, that is 0, this is also 0. Okay, because non-integer samples are not defined. Now, having that much of background, let's start now a very interesting that is a operation on DTS. Okay, let's start now. So the first operation that I am going to cover is a time shifting. Okay, so the first operation is time shifting. Time shifting. Now you know that what is the meaning of time shifting, yes or no? What is the meaning of time shifting? The time shifting is simply that is shifting the signal towards right or left by some values. But here, for example, if I have xn, okay, I have, let's say, consider xn, and I am taking example, let's consider 1, 4, 3, 2 and 5, and here is the arrow. This is simple xn I have, general simple signal I have taken. See, most of the time, 99.99% time, I always use a tabular form to handle any kind of discrete problem, mind it. I do not have to take care, I do not have to always plot this xn and that is do the operation on that's a graphical form of xn. It's not required, it's just a waste of time. Okay, I know that if arrow is defined to me, then I know that this is nothing but my n of 0. So if this is n of 0, this should be n of 1, this should be n of 2, this should be n of minus 1, this should be n of minus 2. That's what. That's the only information I needed. Now my point is that, see, for example, this xn is given to you. If this is xn, then what is the general format of shifting of this function? Okay, what is the general format? The format here is, see, the format is yn is equal to x of same n plus minus of alpha. Okay, but in the last class in the CTS, when this was t, since t belongs to a real number, so this alpha also belongs to the real number. But here there is a change. See, if here n, since n belongs to integer, that's the important thing. So alpha must be integer. Alpha has to be integer. Otherwise, this means that it says the things that if suppose I have a yn which is x of n minus 3 by 2 or yn which is equal to x of n plus 7 by 3, these all operations are not defined, because here it is non-integer, here it is a non-integer, and the n here value should be integer in nature. So what I want to say is that, very simply I want to say is that whenever the shifting operation in DTS you have to take care of, then simply you have to check that whether the shifting factor is integer or not. That is, non-integer shifting is not defined as far as our course is concerned. Why? Because we are taking the integer values of nothing but my TS. Fine. Now then how will you perform this one? See, here the meaning is exactly same. This plus denotes same exactly. This plus denote advancing, this plus denote advancing, and this minus denotes delaying. Exactly the same meaning, exactly with the same meaning. So the plus denotes are advancing and minus denotes are delaying. Okay, now this means that if this is x of n which is given to you, for example, now my point is that, see here, suppose I have to perform, let's take an example. Suppose I want this xn is given, xn is, let's consider 1, 4, 3, 2, 5, and here is my arrow, and this arrow denotes n is equal to 0. Now let's say that I have a yn which is x of n minus of 3, and I have zn which is x of n plus 2. I want the sequence for each and every case. See, how can you perform this one? X of n minus of 3, x of n plus of 2. These are the valid operation because alpha is integer. What this representation says, it says that you have to delay the signal by factor of 3. This means that, for example, if this is at n is equal to 0, this is at n is equal to 1, let's change it. Let's say here, this is n is equal to 1, this is n is equal to 2, this is n is equal to minus 1, this is n is equal to minus 2. This is what? Now what I am doing is that I am shifting this function by factor of what? 3 towards right. This means that you may think this in this way, that you are pushing the whole sequence by right towards right by the factor of 3. Yes or no? So what I'm saying is that if you shift it, if you push it, then this arrow, just concentrate on this arrow. When you shift it, the arrow will move towards a left. Yes or no? If you push it, then the arrow will move towards left. By how many factor? By 3 factor. So okay, here I will get, means at n is equal to -1 and n is equal to -2, I have a sequence. It's okay, sir, but what about the third sequence? Sir, if nothing is there, then everywhere there is a 0. Yes or no? So this means that, what is the sequence for this one? See, the sequence for this one would be what? It should be 0, 1, 4, 3, 2, 5. And here is the arrow. So this means that when you shift the signal towards a right, move arrow towards left by alpha amount. Similarly, exactly the same manner here. See, if you want to shift the signal towards left, this means that you have to pull it instead of pushing. I want to pull the signal by factor of 2. So when you pull the signal by factor of 2, this means that the arrow, instead of moving left, it will move now right by a factor of 2. So this means that it will, for one it will go here, for second one it will go here. This means that what about this one is exactly same, 1, 4, 3, 2, 5, and here is the arrow. So if you know the simple arrow position, then you can shift directly by pushing or pulling, or moving the arrow towards right or moving the arrow towards left. Here, let me write this, that is delaying. So let me write here that for delaying, move arrow towards left by alpha amount. That's a very important case. And here also, for advancing, see, for advancing, move arrow towards right by alpha amount. Simple. So move arrow, just simply move arrow towards right or towards left, you will get the same answer. You will get your answer. You do not have to plot it, you do not have to draw it, simply move the arrow and you will get your answer. Now, point is that, what about width, sir? What about width? See here, look at the width here. It is n is equal to 0. It is n is equal to 0. Let me change the color now. This time, let's use this here, white. See here, look at this. What is the width here? Width is upper bound minus lower bound. So this is at n is equal to 2. This is n is equal to -2. So width here is 2 minus of -2 and plus 1, and hence it is 5. This is a width 5. Width is the number of significant sample. Here, what is width? See here, width here is number of significant samples. So this is the 0th sample, this is first sample, this is second sample, this is third sample, this is fourth sample, and this is fifth sample. Okay? But what about the width, significant sample? Will this 0 count on the width or not? That's what the question is. See, look at this. This 0, though here arrow is present, but we have a significant sample up to this only. We have a significant, because if you count the 0, then why not count from minus infinitive? This is a 0 which is insignificant in nature. This means that this should be what? 5 minus 1. Width should be, width is 5 minus 1 plus 1. 5. Same. Here also. See, look at that. See, this should be what? 0th, significant because it's a finite number, and before means after that it is insignificant, and this should be 0, -1, -2, -3, -4. So upper bound is 0, 0 minus -4 plus 1, which is 5. This is what my width is. This means that, see, listen carefully, this means that I will not change a width while moving the signal towards right or left. What change is the end point? The signal was defined from -2 to 2, but here the signal is defined from 1 to 5. Here the signal is defined from -4 to 0. So end points are changed, but width remains a constant. Yes or no? If these things are clear to you, then please just respond it by thumb. If this thing is clear to you guys, then please respond it by thumb. Hope this is clear to you. That's what the time shifting operation is. Okay. Next operation that we are going to cover is time scaling. Now this is change. Time scaling. Okay. What do you mean by the word time scaling? See, simply, suppose I have a sequence xn. xn which is 1, 4, 3, 2, 5, and here is arrow. This is 1, 4, 3, 2, 5, and that's the arrow we have. Now point is that, simply see here, listen carefully. Now the general format here is yn is x of alpha n, same, but there is no such condition of alpha to be real, to be integer. Here alpha is a real number. Why I am saying this? So this is discrete time, na? It should be integer, na? No, it may be anything. 3 by 2 also is possible, 2 by 3 is also possible, 3 is also possible, 2 is also possible. Why? Let's see, let's look at that. Suppose I have yn as x of alpha n, which is alpha belongs to a real number, and let's take all the possible case. 1, 4, 3, 2, 5, I have a sequence. Let's take an example. Suppose I want yn to be x of 2n. B, I want yn to be x of n by 2. I want yn to be x of minus n. I want yn d to be, yn to be x of minus n by 2, and e, I want yn to be x of minus 2n. See, I have taken the all possible values of alpha. Here in both the case alpha is positive, here alpha is negative, -1, here alpha is greater than 0, less than 1, here alpha is mod alpha is greater than 1. I have taken the all possible cases of alpha. Let's perform this in some different manner. Okay, let's do it. So I have just write xn. Xn is 1, 4, 3, 2, 5. Here is the arrow. Suppose I want a yn to be equal to x of 2n. How will you perform? See here. First take y0. What is y0? Y0 is x0. What is y0? Y0 is x0. What is x0? X0 is given. See, this sample is n is equal to 0. This is n is equal to 1. This is n is equal to 2. This is n is equal to -1. And this is n is equal to -2. These values are defined to me. What is x0? X0 is 3. So it is 3. It is 3. What is y1? Y1, when you put n is equal to 1 value, it is x2. And what is x2? X2 is, see, look at this, x2 is 5. What is y2? Is x4. When you put n is equal to 2 here, it becomes x4. And what is x4? x4 is not defined. So not defined, this means that they are 0. Similarly, let's take a negative value. What is y minus 1? What is y minus 1? When you take y minus 1, it is x minus 2. See? X minus 2. And what is x minus 2? It is 1. X minus 2 is 1. Similarly, y minus 2 is x minus 4. And it is 0 again. And no need to perform further because all the samples beyond 2 and minus 2, they all are 0. This means that if I want to write the yn, the simple yn comes out to be, see, start from here, 0, comma, 1, comma, 3, comma, 5, comma, 0, and here is this arrow. So look at that. This is the y0, this is the y1, this is the y minus 1, this is y2, this is y minus 2. This means that, look at the sample value, it's from minus 1 to 1 instead of minus 2 to 2. So see, what is the width of this function? The width of this function is 3. The width of this function is 3. But what is the width of this function? The width of this function is 5. Width get reduced. Width get reduced. But don't you think that the width reduced by deleting the samples present at n is equal to 1 and minus 1. We don't have a sample present at n is equal to minus 1 of original signal. See, what I am doing is that exactly what I am doing is simply, see, I simply take the sample here, this one, and here. That is, I leave this sample 2 and 4. So this width is reduced by deleting the samples. That is, what I want to say is that, see here, deleting the sample will change the width. And this process is a very famous process, and this process is known as decimation. Decimation. Okay, so what do you mean by the word decimation? See, listen carefully. What do you mean by the word decimation? Decimation means to cut something. So this means that we are cutting a sample. Sir, every time I have to do like this? No, simply see here, if let's say for example for decimation, let me write in this way, for decimation, if yn is x alpha n for alpha greater than 1, what? Take alphath sample starting from origin. Let's take an example. Suppose I have xn to be a comma b c d e f g h I j k l m n o. Here is the arrow. At E, I have an arrow. Simple, I have this long samples. Suppose someone asks you that find the sequence yn which is x of 5n. Let's say not 5n, 4n. Okay. So what we have to take? We have to take alpha sample starting from origin. See, this is the origin. From origin, we have to take 4 samples, or we have to leave 3 samples both the sides. So 1, 2, 3, 4th sample. Then 1, 2, 3, 1, 2, 3, 4th sample. Now, if you take 4 samples from here, this means that leave 3 samples, then you will get a 0. So you will get a 0 here. Here, let's do here. Leave 3 samples and take the 4th one. This one. So this means that what is y4n is A comma E comma 𝐂𝐻𝐼 comma M, and here is R. A comma E comma I comma M. The point is that, see here, listen carefully, this point, this means that I have a sample which are lesser than this. So I deleted this sample, see, I deleted this one, these samples are deleted, these samples are deleted, these samples are deleted, and so on. So these samples are deleted, n minus alpha samples, alpha minus 1 samples are deleted, or you will say alpha minus 1 samples are deleted. Alpha minus 1 samples are deleted. Simple. Is it okay? Now let's take a second one. I have, let's again write xn. Xn is 1 comma 4 comma 3 comma 2 comma 5. Here is the arrow, and but this time I want yn to be x of n by 2. Yn to be x of n by 2. Listen, what is x of n by 2? Simply see here. Let's take now y0 I want, it is simply x0, which is 3, no problem. But y1 if I want, then it is x of 1 by 2. And I told you earlier that x of 1 by 2, 3 by 2, 7 by 2, 9 by 2, 9 by 5, they all are the samples which are non-integer. If they are non-integer, then you do not have to write this one. So this means that this is 0. Similarly, then y2, when you put n is equal to 2, you will get x1 which is equal to 2. Similarly, you will get y3 which is equal to what? X of 3 by 2, and it is again 0. Y4 by 2, again x2 which is equal to 5. And I do not have to go further because after 5 the sequence all are zeros. Okay. Now next is y minus 1 by 2, which is 0 again. Y minus 1 when you put, oh sorry, what I'm saying is y minus 1 is x minus 1 by 2, which is 0. Y minus 2 is x minus 1, which is 4. Y minus 3 is x minus 3 by 2, which is again 0. And y minus 4 is x minus 2, which is 1. Okay. Now when you write all these samples, then you will get a sequence of y and I will get. See here, look at that. What is the y of sequence you will get? So start from here. 1 comma 0 comma 4 comma 0 comma 3 comma 0 comma 2 comma 0 comma 5. And here is the arrow. See, look at the width. When you decide the width here is 5, which was your original width. But here the width you may count. See, these all zeros are significant because they are present in between the samples. I told you many times that in between samples are always 0. So this means that this should be how much? 0. This is 1, 2, 3, 4. 4. This is minus 1, minus 2, minus 3, minus 4, minus 4. And hence the width would be 4 minus of minus 4 plus 1. It is 9. Width is changed. This is what my width is. Hello. So this means that the width is changed. But tell me that if you compare this with your original sequence, then don't you think that I am inserting zeros in between the sample to increase the width? What I am doing actually, I am just inserting zeros. How many zeros? 1 zeros between each samples to increase the width. This means that what? So these all are the samples these all are the zeros which are deliberately placed to increase the width of my function. Yes or no? So deliberately I place the zeros in between the samples, and hence this is a very important operation in signal processing, and we call it to be a interpolation. This process is interpolation. So interpolation, this means that we have a zeros, we have to add a zeros in between the samples. We have to add the zeros in between the samples. That's what the meaning of interpolation is. Okay. So, sir, is there any rule? Is there any format we have to interpolate this segment? Yes, we have. See here, for interpolation, if yn is x of alpha n, where alpha is 1 by k, k belongs to integer. If yn is x of alpha n, okay, and alpha is 1 by k, where k belongs to integer, then append or add, you will say, add k minus 1 zeros between successive samples. Append k minus 1 zeros between the successive samples. That's what the very important point is. So what I am saying is that if we have a k zeros, then we have to add k minus 1 zeros between the successive samples. So if we have, for example, I have let's say xn to be equal to, let's say, a b c d, and here is the arrow, and suppose I want a Zn which is x of n by 3. See, look at that. What is alpha? Alpha is 1 by 3. This means that k is 3. So 3 minus 1, 2 zeros I have to add between the successive samples, and hence my Zn becomes a 0, 0, b 0, 0, c 0, 0, d. After d or before a, you do not have to add zeros because it doesn't have any meaning. Okay, so the point is that these are the zeros, and look at the samples here. It is 8, and whatever you will count, whatever the arrow is at b, arrow will not change, mind it. Okay, so if you count it, simply count it, then this is the increased width version of nothing but my xn. So that's what my interpolation operation is. Now, so third is, let's say, consider xn which is equal to 1, 4, 3, 2, 5, and here is the arrow. Then suppose I want a Zn to be, not Zn, Yn to be x of minus n. Now what we have to do? We have to take the mirror image of a signal. See here, we have to flip the signal. So if you have, see, x of n is, let's say, 1, 4, 3, 2, 5, okay, then see here, around this one, see, around this 3, because this is n is equal to 0, this is n is equal to 1, n is equal to 2, n is equal to minus 1, and n is equal to minus 2. What we have to do is that, see, there is the arrow, this is the arrow. What we have to do is that we have to flip it. This means that, see, this signal is changed by this signal, and this signal is changed by this signal. That's what the meaning of flipping. So if someone asks you x of minus n, then what is yn then? Yn is 5, 2, 3, 4, 1. Here's the arrow. So this is just the, around this, see, around this, we have taken a mirror image. Around this, we have taken the mirror image of a function. So that's what the meaning reversal is. Reversal. And what is the meaning? Take mirror image with respect to origin. So we are taking the mirror image of a function with respect to origin simply. And or you will say that what is the catch? Write signal from back. From back. So we have this signal 1 4 3 2 5, just write 5 2 3 4 1 starting from here, and automatically you will get the reversed version of this function. So x minus n is a reverse version of this function. Now the fourth one is x of minus n by 2 is what my yn is, where xn is again 1 comma 4 comma 3 comma 2 comma 5. Here is the arrow. See here, 1 comma 4 comma 3 comma 2 comma 5. Here is the arrow. Now this time see, yn, since yn is x of minus n by 2, so I have this combination is reversal plus what? See, look at that, the alpha. Alpha is 1 by, mod alpha is 1 by 2. See, what is the mod alpha? Mod alpha is 1 by 2. This means that mod alpha is greater than 0, less than 1. Alpha is 1 by k format. This means that reversal plus I have interpolation. I have reversal plus interpolation. So this means that, see here, look at that. This is a function which I have to first reverse it and then interpolate it by the factor of 2. Reverse it and interpolate it by factor of 2. So first do the reversal. So first reverse. I told you that what do you meaning of reversal? Just write from the back. This means that it is 5 comma 2 comma 3 comma 4 comma 1 here, 5 comma 2 comma 3 comma 4 comma 1, and I have to interpolate it, by 2. What is the meaning? That alpha is 1 by 2. See here, alpha is 1 by 2. This means that what? K value is 2. This means that what? K minus 1 zeros I have to add. Now, how many zeros I have to add? I have to simply add the 0 0 0 0 0 in between the samples. 1 zeros between the samples. This means that what? I have 5 comma 0 comma 2 comma 0 comma 3 comma 0 comma 4 comma 0 comma 1, and the arrow here is 3. Simple. So interpolation is just, we have covered the interpolation. Here alpha is 1 by 2. This means that k is equal to 2. This means that k minus 1 is 1 0 to append, to add. One zeros to be added. Same, exactly same thing. Fifth we can perform. Fifth we can perform. So fifth we have yn is x of minus 2n, where xn is again 1 comma 4 comma 3 comma 2 comma 5. What is x of minus 2n? Now this time again we have yn is x of minus 2n. This means that what we have reversal, definitely reversal, plus, see what is the mod alpha? Mod alpha is 2, means mod alpha is greater than 1. So we have reversal plus decimation. We have reversal plus decimation. And if we have reversal plus decimation, then first perform the reversal. See here, first perform the reversal. Reversal, it is 5 comma 2 comma 3 comma 4 comma 1. Here is the arrow. And now decimate by 2. So second sample we have to take from origin. So we are taking the second sample here and here. So decimation by 2 will gives you 5 3 1. Here is the arrow, 5 3 and 1. So this means that this is the decimation plus what? Reversal. We have decimation plus reversal. So let's summarize everything what we have covered. We have say that we have a time scaling, and we have a general format to be like this. Like this. See, time scaling, we have the format is yn is equal to x of alpha n. Yn is equal to x of alpha n, and if alpha is greater than 1, we call it to be decimation. So what we do? A decimation, if alpha is greater than 0 but less than 1, then we call it to be interpolation. And alpha is equal to minus 1, then we call it to be a reversal. If alpha is less than 0 and if mod alpha is greater than 1, then we have what? Reversal plus decimation. And if mod alpha is greater than 0 but less than 1, then we have reversal plus interpolation. Reversal plus interpolation. So these are the 5 things that we have got. For decimation, what you have to do? For decimation, let's write this also. For decimation, take alphath sample. Take alphath sample starting from origin. For interpolation, if alpha is equal to 1 by k, where k belongs to integer, add k minus 1 zeros between samples. For reversal, take mirror image with respect to origin. So this is what in nutshell, this is what a time scaling operation in, and it is a little bit different from your continuous time operations. Okay, in continuous time you have to simply divide it by alpha, whatever be the values of alpha is. In continuous time, simply you have to divide it by alpha, whatever be the values of alpha is. But here in discrete time, you have to take care of nothing but my alpha and all. You do not have to mug this, guys. When you solve that is a 4 or 5 problems, then automatically it will set on your mind, okay, and automatically your hand will run like a machine. Let's take one of the most example topic here. Okay, fine, just I have to cover the combined operation also. So let's take combined operation here also. Combined operation. And then we will take a gate problem, one gate problem of based on this one. Okay, let's do it. So suppose I have a yn which is x of alpha n plus beta. Now this time I have both scaling as well as shifting operations. Now how many ways are there to handle this one? Here you have to take care, because of the integer factor, you have to take care while performing this one. See here, again there is a multiple way to handle this problem, mind it. Okay, there are multiple ways to handle this problem. See, if you have x of alpha n plus beta, and if you take alpha to be common, see, x of alpha n plus beta by alpha, if you have alpha n plus beta by alpha and you take alpha to be common, then this operation is only performed when if beta by alpha is integer, then only above operation is valid. For example, I have x of minus 2n plus 3, and when you take common minus 2, then it is n minus of 3 by 2, and hence this operation this way you cannot perform. So but here x of alpha n plus beta, if I shift by beta and scale by alpha, then operation is perfectly valid. No matter what kind of operations we have, we can perform this. Means, so in discrete time you always prefer this one, because here there is a factor of integer in this case. Okay, now let's take one interesting gate problem, then only you will able to, that is, understand the whole concept. See here, suppose I have, consider this time, let's change the xn to be minus 2 3 minus 5 7 8 not 8, let's take some lesser value, 4 comma minus 1 comma 3 comma 2. And here's the arrow. Okay, let I have a yn which is, let's say, x of minus 2n plus 6 plus, let's say, 5. Not 5, let's consider it to be 1. So that calculation should be less. X of minus 2n plus 1. And let a sum is defined which is summation n is equal to minus infinity to infinitive mod yn whole square. Then find S, some NAT type of problem. Then find S. Minus 2n plus 1 we have. Let's take here also. Let's compress the signal. Minus 2 by 3n plus 1 and okay, yes, minus 2 by 3n plus 1, and I want to find out this sum. Do it fast. I am giving you 2 minutes. 2 minutes for this one. Giving you 2 minutes. Just give you 2 minutes. Do it fast. Come on. Come on, do it, please. Yes. Let's do it. See here. See, if you take minus 2 by 3 to be here, minus 2 by 3 to be common, then this complete shifting factor will never be the integer. Yes or no? This shifting factor will never be integer. Means what I want to say is that, see here, if I take minus 2 by 3, then this will not be there. So what is defined yn? Yn is x of minus 2 by 3 n plus 1. So what we have to do is that we have to first left shift by 1. First we have to do this. After that, between minus 2 by 3, you are free to choose any operation whatever you want. That is, you decimate by 2, then interpolate by 3 and then reverse, or you interpolate by 3, decimate by 2 and then do the reversal, or first do the reversal, then decimate by 2, then interpolate by 3. Your answer will not change, guys. This means that as long as this operation is concerned, I am free to take free to perform the operation in the manner whatever I want. Okay, so my point is that what I'm doing is that first I'm reversing it, of course, be reversal, 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 and then what I will do is that I will first decimate. Why? Because after decimating, the sequence become lesser. So there is a less chance of error I will make, though answer will not change if you do the interpolation first. Mind it that if you do the interpolation first, then your answer will not change, but I will prefer to do decimate so that my sequence becomes lesser, so that I can handle it properly. Let's do it. Then C, I will do decimate by 2, and D I will take interpolate by 3 by 3. Let's multiply coefficient also in this problem. Suppose I want to multiply coefficient of 2 in this problem. I am changing in between the problem, okay, so that some complexity should be added. Left shift by 1, let's do it. See, when you left shift by 1, this means that I have to pull the signal by 1. Left shift by 1 meaning is this. So this means that arrow will shift towards right by factor of this one. See, so what I want to say is that for A, the sequence would be like -2, 3, 3, -5, 4, -1, 3, 2. Here is the arrow. So whenever you have to what? Whenever you have to simply shift the signal towards left, then you have to simply move the arrow towards right by factor of 1. Now then reverse. Then how will you perform B? How will you perform B? See, simply write from the back. See, whatever it is, should simply flip it. So what if you will say? You will say it is 2, 3, -1, 4, -5, 3, -2. Here. Then what? This is what the reversal is. And then what? Decimate by 2. So how will you decimate by 2? How will you decimate by 2? Simply take the second sample. See, take the second sample. When you take the second sample here, here. Take the second sample here. So that the sequence becomes, what? C becomes 2, -1, -5, -2. Here. And let's do D here. D, interpolate by 3. That's what the meaning, interpolate by 3. Interpolate by 3 means how many zeros we have to add? 2 zeros we have to add. See, 3, this means that 3 minus 1, 2 zeros we have to add. So if you add 2 zeros, then what you will get? You will get, okay, 2 minus 1, -5, -2, no? So 2, 0, 0, -1, 0, 0, -5, 0, 0, and -2. This is the sequence I will get. But this is not the answer. Mind it that I have changed it to multiplied by 2. So the E operation I am adding that multiply each sequence by 2. Sorry. So this will gives me yn to be equal to finally 4, 0, 0, -2, 0, 0, -10, 0, 0, -4. Here is the arrow. Where is the arrow? Here is the arrow, no? Look at the arrow. Arrow position will not change. So this was the arrow. So this is my arrow. Okay? 4, 0, 0, -2, 0, 0, minus 10, 0, 0, minus 4. Now the point is that, see here, listen carefully, what is asked? What is asked? What is asked is that sum S is equal to summation n is equal to minus inverse to infinitive mod yn whole square. So first perform mod yn. Mod yn means take the mod of everything. It becomes 4, 0, 0, 2, 0, 0, 10, 0, 0, 4, and then simply I have to square it and add it. This was the meaning of summation. So the sum is 4 square plus 2 square plus 10 square plus 4 square. Okay, so this is 16 plus 4 plus 100 plus 16. So I think it is 32 plus 4, 36, 136 is the answer. Sum is 136. So these kind of problems you always feel in your GATE examination. Hope that this topic is clear to you. Is it clear? That's what the meaning of nothing but my operation on signals, and I officially say that operation on signals is covered now. Let's come to the new topic. This is the elementary signals. So just 5 minutes left, but let's start this topic at least up to some little extent so that we will cover the topic in tomorrow's class. What do you mean by the word elementary? See, listen carefully. Elementary, this means that fundamental or basics. For example, if you consider the wall in front of you, then this wall is made up of bricks. Yes or no? A lot of bricks are there. They are arranged in a proper manner to get the wall. And when you plastered, you don't not even recognize that particular bricks. So I will say that brick is a fundamental for this wall. Is it clear? Brick is a fundamental for this wall. So this wall is made from arranging the bricks and bricks. Similarly, there are a lot of signals which are made from some basic signals, from fundamental signals. And from these fundamental signals, I will derive that particular signal. So fundamental or means elementary signals are those signals from which higher order signals can be derived. For example, let me take an example. Suppose I have this kind of signal. In the later classes, that is in tomorrow classes, you will know that this signal is actually made up of a 3-step functions, 4-step function basically. Okay, so if you combine the 4-step with a proper coefficient, then you will get this signal. So let me define the elementary signals are those signals. Elementary signals are those signals from which higher order signals are derived. So elementary signals are those signals from which higher order signals can be derived. That's what the meaning of elementary part of the signal is. Okay, so this is what the meaning of elementary signal. And how many elementary signals we have in our course? See here, we have to take the elementary signal first to be a step function, both in continuous as well as discrete. Second is impulse function. Third would be a ramp function. And fourth would be exponential. Exponential, in which I will cover both real as well as complex. And from this complex signal, you will find out that we will get a sinusoids. We will get a sinusoid. From this complex signals, we will get the sinusoids. Okay. So these are the four fundamental signals that we are going to cover in the later class, both for CTS as well as DDS. Okay. Both means these are the signals that we are going to cover in this whole course. Okay, there are many elementary signals also. You will consider sine, cosine to be also a elementary form for some of the basic signals in 4-year series. But the point is that we will just consider up to this exponential, and from that we will take a complex one. So that's what the format that we are going to cover in the next class. So guys, next class is very important. This is the first aspect that I have covered for signal system, but mind it that the next class is one of the most important class, from which I will take the elementary part into be a very detailed manner. Hope that this whole session, what we have covered, let us summarize this one. See here, what we have covered till now. We have, in today's class, we have covered first, that is the operation on DTS. Operation on DTS. And mainly I have covered x-axis operation. Y-axis operation, I don't think that it is required to cover the y-axis operation here, because everyone multiplies the signals by a factor, or everyone adds something to the signals. Though the mathematical operations we will cover throughout the course as the problems come in front of us. So mainly we have covered a time shifting, time scaling, and time reversal, plus combined operation. And then we have just formulate, though I have not taken any word of elementary, but just elementary signals. I have give you the type of the elementary signal. So this is the topic that we covered in our, that is in today's lecture. In the next lecture, mind it that we will cover the elementary signal in detail. And with this, thank you very much. Thank you, because the time is now 8:30. If I start this particular topic, then it will not be completed. So better start in next class. Mind it that class is daily from 7 to 8:30, and please be regular, guys. Please do respect the free initiative that is given to you. And this is the lecture. If you think that I'm giving something different in the paid class, then guys, please, I never do such kind of things in Physics World platform. Also, every teacher, whatever we are giving in a paid platform, we are giving it in YouTube here for free. So if you seriously want your GATE examination to be very awesome or in a flying colors, then definitely you have to respect the initiative. Otherwise, what will happen? After some days, this initiative will also be closed. Okay. So the point is that please respect each and every initiative what is given to you. If you have a doubt, then please do ask the doubt. I'm waiting for you for 1 minute. Hope there is no doubt. Thank you very much.